Look up at the night sky. Everything you can see is only a tiny sliver of what's really there. Stars, planets, gas, galaxies, even you and me are all made of ordinary matter. But astonishingly, that ordinary matter is only about 15% of all the matter in the universe. The other 85% is completely invisible. We call it dark matter. We cannot see it, touch it, or catch it. Yet it shapes the entire cosmos. The first clue appeared nearly a century ago. In 1933, astronomer Fritz Zwicky studied a distant cluster of galaxies. The galaxies inside it were racing around far too fast. The gravity of all the visible stars was nowhere near enough to hold them together. By all rights, the cluster should have flung itself apart long ago. Something unseen had to be adding the extra gravity. He called it dark matter. For decades, his strange idea was largely ignored. Then, in the 1970s, a new discovery brought it roaring back. Astronomer Vera Rubin measured how fast stars orbit inside spiral galaxies. Like a spinning merry-go-round, the outer stars should move slower than the inner ones. But she found the outer stars orbit just as fast as the inner ones. At those speeds, the outer stars should be hurled off into space, unless a vast, invisible halo of extra mass was holding them in. Every galaxy, it seemed, was cocooned in far more dark matter than visible stars. Suddenly, dark matter could no longer be ignored. But how do you prove something invisible is truly there? The answer is that mass bends light, even light from far behind it. A heavy clump warps space, smearing distant galaxies into glowing arcs and rings. By measuring that bending, astronomers can weigh mass they cannot see. And again, they find far more mass than the visible stars provide. The most stunning proof came from two galaxy clusters slamming together. Their clouds of hot gas dragged against each other and slowed in the middle. But the invisible mass sailed straight through, right past the gas. Lensing showed the hidden mass had separated cleanly from the ordinary matter. It was the clearest sign yet that dark matter is a real, separate substance. Dark matter also solved a much deeper puzzle. In the young cosmos, ordinary matter was spread almost perfectly smooth. On its own, it could never have clumped together fast enough to form galaxies. But dark matter, feeling only gravity, began collapsing into clumps much earlier. Ordinary gas then fell into those clumps, and the first galaxies lit up inside them. Across the whole universe, dark matter forms a vast invisible web. Galaxies hang like glittering beads along its threads. It is the hidden scaffolding on which everything we see is built. Without it, there would be no galaxies, no stars, and no us. So what on earth could this mysterious stuff actually be? At first, people guessed it was just ordinary things too faint to see. Burnt-out stars, rogue planets, and small black holes were all suspect. But careful searches showed there simply aren't nearly enough of them. It isn't antimatter, and it isn't a cloud of ordinary gas. Whatever it is, it gives off no light, absorbs none, and reflects none. So most scientists believe dark matter is something entirely new. A new kind of particle, unlike anything in our current textbooks. One leading idea is a heavy, shy particle called a WIMP. Another is an incredibly light particle called the axion. Both would ignore ordinary matter almost completely, feeling only gravity. Billions of them may be streaming through your body every single second. And you would never feel a thing. If they barely interact, how could we ever hope to catch one? So physicists build giant detectors far below the ground. Kilometers of rock overhead block out all the ordinary radiation. Inside, ultra-sensitive tanks wait in perfect silence. They hope to catch the tiny flash of a single dark matter particle striking an atom. Other teams try to create dark matter inside powerful particle colliders. And telescopes scan the sky for the faint glow of dark matter destroying itself. For decades now, these hunts have been running around the clock. And yet, not a single dark matter particle has ever been caught. The most common stuff in the universe remains completely unidentified. Now, there's one thing dark matter is often confused with. It is not the same as dark energy. Dark matter pulls things together with its gravity. Dark energy does the opposite, pushing the whole universe to expand ever faster. Together, the two dark mysteries make up about 95% of the cosmos. Everything humans have ever studied is just that last thin sliver of ordinary matter. We have been studying the exception and missing almost all of the rule. The universe is mostly a darkness we have only just begun to grasp. But the search is far from over. Ever larger detectors and sharper telescopes are coming online every year. Any day now, the very first signal could finally arrive. And it may rewrite our entire picture of reality. For now, dark matter stays hidden, holding the galaxies in its unseen grip. So the next time you gaze at a galaxy, remember, most of it is made of something we still cannot name. A silent, invisible web that quietly built the universe. The greatest unsolved mystery in all of science, hiding in plain sight. If you enjoy this kind of deep science, subscribe, and I'll see you next time.